Look at this breathtaking view, where cutting-edge human ingenuity boldly confronts the raw, ancient power of nature. A masterful twin-track railway gracefully carves its way through steep, active volcanic fields and deep magma chasms. Enormous thermal-shielded tunnels emerge from dark basalt, seamlessly blending safety with futuristic industrial architecture. This $95 billion megaproject stands as a testament to civil engineering, reshaping the geography of danger. Watch how smoothly the heavy yellow automated transport units glide across the heavily reinforced high-grade steel tracks. In the background, nature puts on a terrifying display as the volcanic peak surges with brilliant orange lava. Dozens of high-tech gantry cranes and heavy modular machinery operate in perfect rhythm under a clear azure sky. The vibrant colors tell a story of contrast, where lush surroundings meet the searing heat of liquid stone. Engineers and automated systems work in absolute harmony, meticulously managing structural loads on multi-tier platforms. This flawless orchestration of heavy industrial craft marks a new dawn for high-speed transit in extreme environments. To build a dynamic rail corridor through this fiery hellscape, engineers had to completely reinvent geological mapping tech. Step 1 begins with advanced autonomous drone swarms, mapping subterranean tectonic shifts and hyper-hot lava reservoirs. The heat radiating from the open volcanic fractures instantly tests the endurance of the heavy surveying machinery. Next comes the brutal groundwork, where massive robotic drills begin carving into the hyper-unstable obsidian slopes. Under searing conditions, workers in glowing neon vests manually secure specialized heat-insulating rock anchor bolts. Choking sulfur dust fills the heavy air as these brave crews face intense thermal waves on sheer cliffs. Every single movement is physically grueling, demanding extreme human endurance against the radiant heat of active vents. Following the deep anchoring, high-pressure automated rigs apply a thick layer of advanced aerospace-grade thermal shotcrete. This state-of-the-art concrete shell acts as a primary heat shield, stabilizing crumbling magma-heated cavern walls. The process shifts to heavy logistics, deploying massive heavy-duty transport crawlers carrying modular steel segments. These giant prefabricated steel frame ribs are precision-engineered to withstand colossal shifting structural pressures. Deep inside the glowing underground tunnel, robotic assembly arms lift the heavy rib structures into place. Exhausted crews, drenched in sweat, monitor the hydraulic alignment as loose molten rock sparks nearby. Outside, the project scales up to the canyon gaps, where colossal automated cable crane systems are erected. Gigantic structural segments for the bridge are slowly transported over deep, active rivers of boiling lava. The intense updrafts from the magma test, the computerized stabilization systems of the heavy lift cranes. On the high scaffolding, structural welders brave the toxic gases to permanently lock the massive steel joints. Next in the assembly line is the installation of high-volume automated liquid nitrogen cooling pipes. These cutting-edge integrated cooling systems prevent the high-grade steel tracks from warping due to intense heat. A continuous chain of advanced heavy mechanical operations, pushing the boundaries of modern structural engineering. With the cooling networks established, the pipeline transitions to the installation of high-frequency seismic blast shield. Suddenly, an unexpected seismic tremor shakes the foundation, causing large boulders to violently rain down. Unfazed by the imminent danger, the dedicated crew in neon gear fiercely sprints to secure shifting supports. The next step focuses on the structural fusion of advanced carbon fiber containment barriers along the fault line. A sudden burst of hyper-pressurized toxic gas ruptures from a nearby vent, engulfing the lower assembly floor. crews with heavy oxygen respirators push through the zero-visibility sulfur cloud, locking down ventilation valves. Once the air is stabilized, massive autonomous grinding vehicles move in to plane the reinforced high-grade rails. A shower of brilliant friction sparks illuminates the dark tunnel as the grinding wheels smooth the steel. The operation scales outside to the active slope, where workers assemble advanced automated lava deflection walls. Without warning, a fast-moving overflow of molten rock breaches the rim, rushing toward the working platform. The focus team stands their ground, skillfully coordinating giant crane maneuvers to block the thermal wave. Following the line, engineers install a massive network of fiber optic stress sensors beneath the track bed. These smart sensors form an electronic nervous system, measuring real-time structural deformation from ground shifting. The process advances to heavy electrification, lifting massive copper overhead catenary lines across the volcanic chasm. A flawless continuity of extreme industrial engineering, marching closer to conquering this untamable, fire-ravaged valley. With electrification complete, the assembly line installs advanced automated magma drainage sluices alongside the tracks. Without warning, a sudden, high-pressure underground lava surge ruptures the newly carved lower structural embankment. Brave workers in neon gear rush toward the breach, determinedly positioning heavy-duty thermal containment plates. The heat spikes to extreme levels as the crew manually clamps the high-grade industrial shielding into place. Next in the sequence is the critical deployment of automated hyperbaric airlocks at the tunnel entrance. Suddenly, a mechanical failure strikes the primary ventilation system, trapping toxic carbon monoxide gas inside. Working through near-zero visibility, the team fiercely fights the gas buildup, resetting digital backup generators. Once pressure stabilizes, massive mechanized track stabilization vehicles roll out to perform precision geometric load testing. Heavy hydraulic stabilizers press down on the rails, creating intense vibration echoes through the volcanic valley. The process moves to the high canyon, where technicians mount primary automatic fire suppression cannons. A massive overhead volcanic explosion sends a wave of blinding white-hot ash and toxic embers toward them. Hanging from high safety lines, the crew continues welding the automated cannon mounts with relentless effort. The next step requires linking the massive line to the centralized digital command network via fiber highways. Technicians delicately splice ultra-dense data cables while rivers of liquid fire churn deep inside the gorge. Every single link in this monumental assembly line pushes human endurance and machinery to the absolute edge. Following data cable integration, the manufacturing process advances to installing automated seismic dampening base isolators. Without warning, a massive localized magma quake rocks the bedrock, tearing a fissure through the outer rail siding. The disciplined crew in neon gear springs forward, dragging heavy composite structural splints to the breach. Extreme heat ripples from the fracture as the team works tirelessly to lock down hydraulic stabilizing braces. The line sequence now moves to the integration of automated plasma-cutting field blast gates within the tunnels. Suddenly, a dangerous volcanic gas pocket ruptures, releasing a wave of glowing toxic embers into the sector. Braving the near-zero visibility, the exhausted workers fiercely push through soot to manually seal intake valves. Once atmospheric pressure stabilizes, massive laser alignment vehicles roll onto the tracks for geometric validation. Intense neon green laser grids scan the steel rails, throwing sharp structural diagnostics onto field monitors. The assembly chain moves to the cliffside, where technicians begin mounting advanced geothermal heat extraction pylons. A sudden explosion from a lower volcanic vent hurls a massive wave of black ash and heat upward. Secured by industrial safety harnesses, the crew relentlessly continues securing the pylon base with unwavering focus. Next, the process links these heat extraction pylons directly to the automated liquid nitrogen processing plant nearby. Technicians carefully connect insulated high-pressure coolant conduits while boiling rivers of magma churn far below. Every intricate mechanical step in this relentless industrial assembly chain demands flawless spirit and machinery. Moving forward from the cooling infrastructure, the assembly sequence shifts to installing advanced magma-level sensors. Without warning, a massive, pressurized subterranean magma surge ruptures a critical section of the valley wall. A courageous crew in neon gear immediately rushes inside, carrying massive composite thermal plates to cover it. Blistering radiant heat warps the air as the workers manually lock down heavy hydraulic structural shoring. The next step focuses on the integration of automated high-velocity ventilation dampers inside the deepest cavern. Suddenly, an unexpected volcanic pressure pocket bursts, releasing a cloud of glowing toxic ash into the zone. Braving near-zero visibility, the exhausted crew aggressively pushes forward to manually override emergency blast valves. Once atmospheric levels normalize, massive heavy-duty laser scanning vehicles roll onto the tracks for monitoring. Intense neon green laser arrays slice through the dim air, sending real-time geometric telemetry to screens. The process advances to the open slope, where engineers deploy computerized electromagnetic landslip stabilization anchors. A sudden explosion from an adjacent volcanic fissure hurls a violent wave of searing embers and ash upward. Secured by safety lines, the dedicated crew continues welding the massive pylon structures with deep focus. Following the pylon setup, the manufacturing line mounts automated high-volume nitrogen gas suppression tanks. Industrial technicians carefully connect thick, reinforced high-pressure alloy conduits while liquid stone churns far below. Every single movement in this monumental industrial chain highlights the pinnacle of human labor and machinery. With gas suppression operational, the assembly chain advances to installing high-frequency tectonic shock absorbers. Without warning, a violent subsurface magma displacement triggers an explosive shockwave, cracking the viaduct foundation. The unified team in neon gear leaps across split gaps, hoisting heavy carbon composite reinforcement sleeves. Searing volcanic steam rises fiercely from the cracked floor as the crews anchor hydraulic stabilizing braces. The assembly pipeline moves forward to integrating automated thermal insulated blast gates within the intersections. Suddenly, a pressurized thermal line ruptures inside the tunnel, spraying superheated water and steam into the sector. Braving the zero-visibility scalding mist, exhausted workers push forward to manually clamp secondary release valves. Once the internal pressure drop stabilizes, massive rail rectification vehicles crawl into position for alignment testing. Intense neon green laser grids blanket the steel lines, sending real-time structural analysis to Central Command. The workflow expands onto the sheer outer ridge, where technicians assemble electromagnetic lava flow diversion fields. An unexpected secondary eruption hurls a massive wave of black ash and flying embers over the scaffold. Suspended from industrial safety lines, the crew continues welding the massive deflection armor with hard work. Following shield installation, the construction sequence places heavy automated emergency brake systems along the lines. Technicians meticulously connect armored pneumatic pressure lines while bubbling rivers of magma churn far below. Every intricate mechanical task in this conveyor line demands absolute human dedication and futuristic engineering. Following emergency brake integration, the assembly line moves to deploying automated thermal shielding barriers. Suddenly, a high-pressure molten rock burst splits the subballast, pouring glowing magma across the rails. Without hesitation, the brave crew sprints into the blistering zone, hauling giant tungsten insulation plates. Searing radiant heat bends the air, as focused workers manually lock down hydraulic stabilizing clamps. The workflow now transitions to the crucial integration of automated vacuum extraction dampers in the network. Suddenly, a toxic volcanic pressure pocket explodes, filling the tunnel with glowing embers and dark soot. Braving the near-zero visibility, the team fiercely fights extreme conditions to engage primary intake valves. Once internal air pressures normalize, massive ultrasonic rail testing vehicles roll onto the lines for load analysis. Intense neon green digital laser grids slice through the darkness, scanning for microscopic thermal fractures. The assembly chain moves to the volcanic slope, where technicians begin mounting early warning telemetry pylons. Without warning, a violent secondary explosion hurls a wave of white-hot ash onto the structural framework. Hanging from safety lines, the dedicated crew continues welding complex electronic pylon components with effort. Following telemetry setup, the construction sequence places liquid nitrogen injection points beneath the foundations. Industrial technicians carefully seal reinforced high-pressure alloy coolant conduits while boiling rivers of stone churn. Every single movement in this industrial conveyor system represents the ultimate triumph of human labor. With all active volcanic shielding systems in place, the assembly line installs automated high-capacity rail power grids. Suddenly, a tremendous ground tremor rips open a geothermal fissure, threatening the fresh power substations. The highly coordinated team in neon gear acts instantly, locking heavy magnetic clamps onto the shifting framework. Now, the sequence initiates the integration of central automated emergency pressure valves within the operations facility. Without warning, a massive volcanic ash cloud breaks from a vent, engulfing the monitoring towers in darkness. Working through the burning ash storm, the exhausted crew pushes forward to manually calibrate control sensors. Once all vitals normalize, massive automated multi-point diagnostic trains move out to execute comprehensive grid tests. Brilliant green laser grids illuminate the tracks as computerized telemetry systems verify micromillimeter alignment. The final connection is made, linking the entire transit corridor to the main infrastructure hub near the ridge. Look at this spectacular finished modern marvel, standing as an unyielding fortress above a river of magma. Inside the newly constructed subterranean transit terminal, futuristic architecture merges flawlessly with heavy industrial engineering. Vibrant blue and orange LED digital flight information display boards glow against the polished charcoal walls. Sleek, modern metal waiting benches with integrated blue neon accent lighting are organized across the platforms. High-volume automated environmental ventilation pods pulse quietly, maintaining a pristine, cool climate deep inside. This documentary is for education only, based on real sources. Theories are not facts. With the inner terminal secured, the final integration shifts to linking external geothermal energy collectors to the grid. Suddenly, a critical alert signals an unforeseen lava wave threatening the external transformer array. The response team in neon gear instantly deploys, manually anchoring heavy robotic shielding walls along the boundary. Watch how the intense external volcanic fire beautifully illuminates the massive, completed multi-tiered rail bridge infrastructure. This documentary is for education only, based on real sources. Theories are not facts.